Project Management Professional Training Session 8 Part 1. Planning Quality and Risk Management. PMP Exam Objectives: What it really means. 2.8 Develop the Quality Management Plan. Develop the quality management plan and define the quality standards for the project and its products based on the project scope, risks, and requirements in order to prevent the occurrence of defects and control the cost of quality. Understand that the plan quality management process generates two main output documents, the quality management plan and quality metrics. Know how the risk management plan is input to this process and can be modified during the process, and details like that. PMP Exam Objectives: What it really means. 2.10 Plan for risk management. Plan for risk management. By developing a risk management plan, identifying, analyzing, and prioritizing project risk, creating the risk register, and defining risk response strategies in order to manage uncertainty and opportunity throughout the project lifecycle. That covers all the risk processes discussed in this chapter. It's enough to just remember the names of the input, tools, and techniques, and output. You should know what is in a given input item that the given process uses and how it helps in generating the output, as well as what a given tool or technique does in a given process. You should understand very well how to apply risk tools and methods, such as probability and impact matrices, risk breakdown structure, RBS, SWOT analysis, root cause analysis, decision tree analysis, and EMV analysis. Know how to perform simple risk calculations. Quality and risk are interrelated aspects of any project and need to be managed. While quality refers to the degree to which a set of completed characteristics of project deliverables and objectives fulfills the project and product requirements, risk refers to an uncertain event or condition that, if it occurs, has a positive or negative effect on meeting the project objectives. Project work is incomplete without implementing quality, and an incomplete project is obviously a failed project. It is about delivering the complete and correct product in the right way. The right way refers to the project quality, example, according to planned schedule and cost. In other words, the core objective of quality management is to ensure that the project will satisfy the needs and requirements for which it was undertaken. Accordingly, quality management consists of three core elements: planning quality management, managing the quality, and controlling the quality. Quality management includes managing the quality of both the project and its product. Whereas the techniques of product quality management, such as measuring the quality, may depend on the type of product, the techniques for project quality management are independent of the type of product. Quality is affected by uncertainties. Uncertainties are all around us and in our projects. After the project starts executing, you will not have enough time to plan a response to a risk if it occurs, so you need to plan the risk responses before the project starts executing. To do that, you need to identify the risks and analyze them. Not all risks are equal. You prioritize the risks based on the analysis, plan responses accordingly, and implement the risk response plan. Also, you need to monitor the risks and their overall management. In this chapter, besides presenting the big picture of quality and risk, we will discuss the planning processes of both quality and risk management. The core question in this chapter is, how do you plan for quality and risk management? In search of an answer, we will explore three avenues: planning quality, identifying and prioritizing by analyzing risks, and planning risk responses. Managing quality, big picture. The knowledge area covering quality has three processes as explained in the following list. Plan quality management. This process is used to identify which quality requirements and standards are relevant to the project at hand and how to determine that the project and its deliverables meet these requirements and conform to the standards. Key: identify quality requirements. Manage quality. This process develops tests, evaluation procedures, and other activities based on the quality management plan and quality control measurements taken in the control quality process. Key: develop tests and evaluations. Control quality. This process executes the activities developed in the manage quality process to verify that the project and its deliverables meet the quality requirements and conform to the quality standards. Key: verify by executing the activities. Table 7.1 presents the list of processes of quality management along with the major output of each process and the process group to which it belongs. Caution. In addition to the 3 quality management processes shown in Table 7.1, the performing organization might have its own quality policies and procedures, which will need to be and are incorporated into quality management by the managed quality process. The big picture of quality management is presented in Figure 7.1, where 2 processes named in oval-shaped boxes do not belong to quality management but, as shown, interact with it in an important way. 2 outputs, quality reports and verified deliverables, of quality management are used by processes in other knowledge areas. Before talking about quality planning, let's take a look at a few quality concepts. Some concepts in quality. In this section, we will discuss some general concepts in quality. While deal ing with quality, you should be able to distinguish between the terms in the following pairs. Grade and quality. Grade is a category assigned to products with the same overall functional use but that differ in their technical characteristics and features, whereas quality is the degree to which the inherent characteristics of a product meet the requirements. Number of defects is an example of poor quality, whereas a limited number of features is an example of low grade. Precision and accuracy. Precision is the spread of different measurements of the same quantity, constant, or variable, such as gravity or cost. The smaller the spread of measured values is, the better the precision. Accuracy is a measure of how close the measured values are to the true value of the quantity. The closer the measured value is to the actual, or true, value, the better the accuracy of measurements. Prevention and inspection. Prevention is a direction to perform an activity that will keep an error from entering the product and the process. Inspection is a technique to examine whether an activity, component, product, result, or service complies with the planned requirements. So, the goal of inspection is to ensure that errors do not reach the customer. Note, although quality treatment in PMBOK does not talk about precision and accuracy that much, we have discussed these concepts here due to its importance for project managers. Project management and quality management have come a long way as separate disciplines of knowledge and practice. It should not come as a surprise that quality management is one of the 10 knowledge areas in standard project management. In a complementary way, both modern quality management and project management recognize the importance of the following critical issues. Continuous improvement. Continuous improvement means to keep improving the quality through a process of planning for quality, implementing qual-ity, auditing quality, and replanning based on lessons learned or auditing. So, really, quality improvement is an endless cycle, called the Plan-Do-Check-Act cycle, as defined by Shewhart and modified by Deming. Performing organizations can also use techniques such as Six Sigma TQM to improve the quality. Customer satisfaction. Customer satisfaction can be a very vague notion that could mean different things to different parties. However, in project management and quality management, customer satisfaction means that planned customer requirements are met. To achieve customer satisfaction in the real world, you need to understand, define, and evaluate the customer's expectations and also manage those expectations, in addition to meeting the planned requirements. Otherwise, you might meet the planned requirements, and the customer might still be dissatisfied. Bypassing the proper quality procedure will cost customer satisfaction and lead to more being spent on rework. Management responsibility. This refers to the responsibility of the management to provide the resources needed for the project team to succeed. Although all team members should be responsible for the success of their parts of the project, they cannot succeed without management responsibility. Prevention over inspection. One of the fundamental tenets of modern quality management is plan, design, and build in quality as opposed to inspect in. The cost of preventing mistakes is much less than finding them through inspections and then fixing them. Therefore, cost of quality, COQ, is less via prevention than through inspection. The COQ is defined as the total cost of quality-related efforts throughout the product lifecycle. Study Checkpoint 7.1. You are trying out a Monte Carlo simulation program that estimates the value of a parameter by using some random variables. You know through the data that the exact value should be 40. You ran the program 3 times, and it gave you 3 values, 50, 51, and 52. Based on these values, answer the following questions. Q1. How precise is the program in making the estimates? Q2. How accurate are the estimates? Q3. Are the values generated by the program more accurate or more precise? The process for managing quality is part of executing the project. quality control is part of monitoring and controlling the project, and quality planning is performed during the project planning stage and is discussed next. Planning quality. Plan quality management is the process used to accomplish the following. Identify quality requirements and standards for the ECT and its deliverables. Determine how to test and verify that the quality requirements have been implemented and that the standards have been conformed to. Table 7.2 presents the plan quality management process in terms of input, tools and techniques, and output. Core of planning quality management. As discussed earlier, planning quality management consists of identifying quality requirements and standards for the project and its deliverables and determining how to test and verify that those quality requirements have been implemented. To make sense of the following material, you should know the story of how quality management involves the project and its stakeholders. The stakeholders have some project and product needs and requirements, including quality requirements, the fulfillment of which is affected by quality-related assumptions and constraints. In light of this, performing the plan quality management process may be explained in the following steps in terms of the items from Table 7.2. 1. Get background and reference how to information from the requirement management plan, extract the information on how the requirements were identified, analyzed, and managed. As stakeholders' needs and expectations are crucial to managing quality, get the information from the stakeholder engagement plan on what methods were used to document the stakeholders' needs and expectations. As risk and quality are closely related, get information from the risk management plan on how risks were identified, analyzed, and monitored. 2. Determine quality standards. Quality standards and quality objectives can, at least partially, be determined by using the WBS and the deliverable section of the project scope statement, which are parts of the project scope baseline. The acceptance criteria for deliverables is the scope baseline, and measurable project objects linked to project success criteria in the project charter will also help with this determination as well as influence the quality management. 3. Get information about deliverables and quality requirements. Fetch the quality requirements for the project and its product from the requirement documentation. Then, link the product requirements to deliverables using the requirements traceability matrix. This helps make sure that each requirement is tested through the managed quality process. The requirements will be compared with the actual project results in the control quality process. 4. Get quality assumption and risk information. Extract quality-related assumptions and constraints from the assumptions log. Get the risks and opportunities that can influence or impact quality from the risk register. These assumptions and risks are used to determine how to perform the manage quality and control quality processes. 5. Get stakeholder information. Use the stakeholder register to identify the stakeholders with a specific interest in a specific quality item. This will help with prioritization, example, quality interests, customers, and the project sponsor will be high in the priority list. This information will also help to determine how to perform the manage quality and control quality processes. 6. Use the tools and techniques listed in Table 7.2 to convert the information from steps 1 through 5 into quality metrics and a quality management plan. If the performing organization lacks a quality policy, the project team will need to develop a quality policy for the project. Once a quality policy is in place, it is your responsibility to ensure that the project stakeholders are aware of it and are on the same page. Some of these tools are explained in the next section. Tools and techniques used for quality planning. The tools and techniques used for quality planning include benchmarking, cost-benefit analysis, experiment design, brainstorming, and more. Data gathering techniques. The following data gathering techniques can be used to gather data in order to identify quality requirements and standards and for other matters regarding planning quality management. Benchmarking. Benchmarking is comparing the practices, products, or services of a project with those of some reference projects for the purpose of learning, improving, and creating the basis for measuring performance. These reference projects might be previous projects performed either inside or outside of the performing organization. Improvement and performance are of course quality-related factors in this case. For example, you might have performed a similar project in the past that accepted no more than 2 defects in each feature. You might use that as a quality criterion, a benchmark, for your current project. The benchmarked project could be in the same or a different industry as your project is in the same or a different application area, and inside or outside the performing organization. Brainstorming and interviews, covered in chapters 3 and 4, can also be used for data gathering in this process. For example, brainstorming sessions in a group environment can be held with team members and quality experts while developing the quality management plan. Similarly, interviews can be conducted with appropriate stakeholders to collect information regarding planning quality matters, such as project and product quality needs. Data analysis. To select the best of the alternatives available when implementing quality, the following data analysis techniques can be used. Cost of quality. Cost of quality is the total quality-related cost during the life cycle of the project and its product. That includes the costs incurred in implementing conformance to the requirements as well as the cost of non-conformance. The cost of conformance consists of prevention costs and appraisal costs. Prevention costs include the costs of implementing quality, such as for appropriate equipment, documenting and performing processes, time and effort needed to perform the project work the right way, and any necessary training of the team members. The appraisal costs include the cost of inspecting, testing, and loss due to destructive testing. Destructive testing refers to tests in which the product under test is destroyed or harmed by design. Cost of nonconformance refers to the cost of failure, both the internal failure and external failures. Internal failures, or failures found during the project, include rework and waste. Example, product is rejected internally because it did not meet the quality standards, so it's now scrap. External failures, or failures found by the customers, include warranty work and more fatal consequences, including liabilities and loss of business. Cost-benefit analysis and decision-making techniques. During qual-ity planning, you must consider the trade-off between the cost and the benefit of implementing quality, then strike the appropriate balance for a given project. Cost-benefit analysis is performed to choose the best of several alternatives available in implementing quality. The chosen alternative will have minimum work and cost, and maximum productivity and rise in stakeholder satisfaction and expected benefit. The decision-making technique of multi-criteria decision analysis can be combined with cost-benefit analysis to help select the best of the alternatives available in implementing quality. This decision-making technique can be used for decision-making in other quality planning matters, such as prioritizing quality metrics. Data presentation. Data presentations are used for various purposes. 1. Examine data integrity. 2. Find the key quality metrics and quality requirements. 3. Understand and estimate the cost of quality for a process. 4. Improve the process. And 5. Identify points where quality defects may occur. Some of these ideas are discussed next. Matrix diagrams. This method is used to explore the strength of the relationships between different entities, such as objectives and causes, by displaying these entities in a matrix, with the cells of the matrix representing the relationships. These relationships are explored to find the key quality metrics important for project success. Logical data model. In this technique, the relevant data from the organization is visually presented in business lingo and does not depend on any specific technology. This is visual display of how quality-related logical loopholes such as data integrity are discovered. Mind mapping. This is a diagram technique, explained in Chapter 4, in which ideas from information collected through various means and methods are mapped around a central or key concept to expose commonalities and differences among them. In quality planning, each key concept would be a single quality concept linked to various ideas around it. This technique may help with figuring out quality requirements, constraints, and relationships, such as dependencies. Test and inspection planning. When, during the planning stage of your project, you are planning the tests and inspections of the project outcome to see if it meets the stakeholders' needs and expectations, as well as the project and outcome goals, ensure that these tests and inspections cover the quality aspect as well. These quality-related tests and inspections would depend on which industry the project belonged to. Example, field test in some sciences, inspection in manufacturing, strength test in construction and manufacturing, and alpha-beta tests in software engineering. Flowcharts, also called process maps. Flowcharts visually display the sequence of steps of a value chain, including the process converting input into output. As in a value chain, flowcharts, in general, may include activities, decision points, branching possibilities, and parallel paths. As a simple example of a flowchart, Figure 7.2 presents a version of a value chain called SIPC, which stands for supplier, input, process, output, and customer. How do you obtain information from these flowcharts? The answer: 1. Figure out the frequencies associated with the workflow branches, example, probability of cost of quality conformance being $10,000, and probability of cost of quality nonconformance being $15,000, and 2. Use these frequencies to estimate the monetary value of quality conformance, as well as the cost if rework is needed in case of nonconformance. These flowcharts have multiple uses, including 1. Understanding and estimating the cost of quality for a process, 2. Improving the process, and 3. Identifying points where quality defects may occur. Of course, you will be holding meetings to collect information and develop the quality management plan. Caution! Part of the cost of quality is the failure cost, which is the cost of the rework needed because of the failure to meet the requirements during product development. Failure cost, also called cost of poor quality, is grouped into two categories: external failure cost, which is the cost of fixing problems found by the customer, and internal failure cost, which is the cost of fixing problems found within the project. Failures that occur at the hands of the customers can also result in fatal consequences, including lawsuits and loss of business. You usually use more than one of these techniques to generate the output of quality planning. Output of quality planning. Major outputs of the quality planning process are the quality management plan and quality metrics. Quality management plan. The quality management plan contains the following information. What are the quality-related roles and responsibilities assigned to each role? What are the project and deliverable quality requirements and standards for this project? Describes what and how the quality-related policy, procedure, and guidelines will be applied in order to achieve the project quality objectives, example, procedures to deal with continuous improvement, nonconformance, and corrective action. What resources will you or project management need in order to meet the project quality objectives, example, the quality tools to be used. What are the quality objectives for this project? Describes activities of the quality management and quality control processes for this project. Which deliverables and processes will go under quality review? This plan becomes a component of the overall project management plan. Tip: whether the quality management plan is informal and high-level or formal and detailed depends upon the size, complexity, needs, and requirements of the project. Quality metrics. A metric in quality metrics is a product attribute accompanied by the information on how the quality control process will verify its quality conformance. For example, it is not specific enough to say that the defects in the product will be minimized. Rather, specifying something, such as that no feature will have more than 2 defects, is a measurable criterion and hence a metric. Some examples of quality metrics are cost performance in CPI, schedule performance example, percentage of task completed in time, defect frequency example, number of defects experienced per day, failure rate, and downtime per week. The metrics that you set during quality planning will be used in quality management and quality control. Study Checkpoint 7.2. Knowing the plan quality management process, answer the following. Q1. Describe which EEFs can influence this process. Q2. Describe which OPAs can influence this process. Q3. Describe how the documents listed in the output column of Table 7.2 will be updated. Note that quality planning might influence other planning processes. For example, implementing the identified quality standards will impact the cost and the schedule directly or indirectly. Furthermore, the implementation of a quality characteristic might require a risk analysis of the problem that the quality characteristic addresses. This is reflected in the fact that the risk management plan is an input to the quality management plan, which also shows that in-sync development and implementation of the quality management plan and the risk management plan is crucial for project success by delivering the right and complete product. Managing risks, the big picture. To most of us, risk means danger. If it happens, it will result in negative, undesired consequences. However, in project management, risk is an uncertain event or condition that, if it occurs, has a positive or a negative impact on meeting the project objectives related to components such as schedule, time, cost, scope, or quality. Negative impact poses a threat, and positive impact offers opportunity. For example, one of the obvious schedule objectives for a project is to complete the project by the scheduled deadline. If a risk related to the schedule occurs, it can delay the completion of the project, or it can make it possible to finish the project earlier. So, the two characteristics of a risk in project management are the following. It stems from the elements of uncertainty. It might have negative or positive effects on meeting the project objectives. Risk management includes planning risk management, identifying and analyzing the risks, planning and preparing risk responses, implementing the risk response if the risk occurs, and monitoring the risks. Figure 7.3 shows the corresponding processes used to accomplish these tasks, which are also explained in the subsequent list. Plan risk management, a process to determine the hows of risk management, such as how to conduct risk management for the project at hand. Example, what will the risk management activities be and how will they be performed? Identify risks, a process to identify and document the risks that might occur for the given project, and also sources of overall project risk. Perform qualitative risk analysis, a process used for estimating the overall probability that risks will occur, as well as their impact, and prioritizing them accordingly for further analysis. Perform quantitative risk analysis, a process used to analyze numerically the effect of identified risks on meeting the project objectives. Plan risk responses, a process used to prepare a risk response plan in order to increase the positive impact and decrease the negative impact of risks on the project. Implement responses, the process implement responses makes sure that all the planned risk responses are executed as planned. Monitor risks, this process is used for tracking identified risks, identifying new risks, and executing and evaluating the effectiveness of the risk management processes. Tip: the data flow between the different processes shown in Figure 7.3 is true in general. However, note that depending upon the project and the experience of the risk management team, shortcuts can be taken. For example, you can go directly from risk identification to quantitative risk analysis, or even to risk response planning, or you need only qualitative risk analysis and not quantitative risk analysis. These processes are listed in Table 7.3 with the major output from each process. The implement risk responses and monitor risks processes are part of the executing process group and the monitor and control process group, respectively, whereas all other risk management processes belong to the planning process group. It's evident that planning risk management demands a considerable effort. Planning risk management. Risk management planning is the process used to determine how the risk management activities for the project at hand will be performed. The major goals for planning the risk management are threefold: ensure that the type, level, and visibility of risk management fit with the actual risk involved in the project and the importance of the project to the organization, secure sufficient resources, including time for risk management activities, and set up an agreed-upon basis for evaluating risks. In a nutshell, you use the risk management planning process to determine the following: the risk management activities for this project. How to execute the risk management activities. Table 7.4 presents the planned risk management process in terms of input, tools and techniques, and output. Developing the risk management plan. You perform risk management planning to develop a document called the risk management plan. Take a closer look at the input column of Table 7.4, but ignore Item 2. We have the project charter, used to start the project, the stakeholder register, which contains information about project stakeholders, and the project environment in terms of the enterprise environmental factors and organizational project assets. In other words, we have a project, with its environment and stakeholders, that has just started. Now, add Item 2, i.e., all the plans from the start to the completion of the project. That is what it takes to manage risks, the whole project. Risks could be anywhere, and you should look for them in all aspects of the project. As risk management should initially be planned very early in the project, we need the project charter, which contains a description of the project and its scope, including boundaries, requirements, and risks. From the project register, you can learn about what roles different stakeholders are playing in the project and what their attitude is toward and relationship is with different types of risks. This will help in planning risk management, i.e., determining risk management roles and responsibilities and risk threshold by performing stakeholder analysis as described in Chapter 8. The enterprise environment factors relevant to risk planning include the overall risk threshold set by the organization or the key project stakeholders. The organizational process assets relevant to risk planning include organizational risk policy, i.e., approaches toward risk management, definitions of concepts and terms about risk used within the organization, standard risk templates you can use, a roles and responsibilities list, authority levels for decision-making, and lessons learned from similar projects. You develop the risk management plan by holding planning meetings with relevant stakeholders, such as project manager, selected members from the project team, selected stakeholders, any member from the performing organization who has responsibility for risk planning and executing. All these efforts generate a document called the Risk Management Plan. Risk Management Plan. The only output of the plan risk management process is the Risk Management Plan, which includes the following elements. Strategy and methodology. The strategy refers to the general approach of handling risks for the project underway, while the methodology specifies the system of approaches, tools, and data sources that will be used to perform risk management on the project at hand. Note that these tools and approaches might vary over different projects, so you have to make the best selection for the given project. Identifying and assigning resources. This identifies the need for the resources for risk management, such as human resources, cost, and time. Roles and responsibilities. This specifies the roles and responsibilities for each role involved in risk management. These roles are or will be assigned to the members of the risk management team. Funding. The cost of risk management activities needs to be estimated and included in the budget and the project cost baseline. Timing and scheduling. The plan specifies how often the risk management processes should be run and what activities executed in these processes should be, which will be included in the project schedule that is planned and developed by using the processes discussed in Chapter 5, Project Schedule Management. Tip: it's a good idea for the risk management team to include members from outside the project team to ensure unbiased risk evaluations. Stakeholders' risk tolerance. For each key stakeholder, the risk tolerance in terms of measurable threshold of objection, i.e., the point beyond which complaints would start coming in, should be recorded. These threshold values should be taken into account when assessing the priority of individual risks. Risk categories. This element, to facilitate the identification of individual project risks, specifies how the risks will be categorized. The risk categories typically correspond to the sources of risks. Depending upon the size and complexity of the project, you might need to develop a risk breakdown structure, RBS, which is a hierarchical structure that breaks the identified risk categories into subcategories. In developing this structure, you will end up identifying various areas and causes of potential risks. The performing organization might already have prepared a categorization of typical risks. However, you need to examine this categorization for each project and tailor it according to the needs of the project at hand. The risk categorization helps you identify risks to the extent that you will be identifying various areas and causes of potential risks for your project. Caution: some project management literature uses the terms risk sources and risk categories synonymously. Be ready to handle it if it happens in the PMP exam questions. Definition of risk probability and impact. Defining different levels of risk probabilities and impacts is necessary to ensure the quality and credibility of the qualitative risk analysis, which we will discuss later in this chapter. The basic issues are defining the scale of likelihood that the risk will happen and defining the scale of the strength of its impact if the risk occurs. These definitions, even if they already exist in the organization, must be examined and tailored to the needs of the specific project. In qualitative analysis, we are talking about relative impact levels. As an example, Table 7.5 shows the risk impact definitions for 4 project objectives: cost, quality, scope, and time. Note that this example only shows the negative impact. The first row of the table presents the impact scale, and each cell in the following rows from column 2 to column 6 specifies the impact on a specific objective corresponding to a point on the overall impact scale. For example, the cell corresponding to second row and fifth column reads that high impact, 0.65, means a 50 to 80% increase in cost. You can define the risk probability scale from very unlikely to almost certainly, called the relative scale. As an alternative, you can define a numerical scale in which the probability is represented by numbers, so a value close to 0.0 means very unlikely and a value close to 1.0 means almost certainly. The impact scale represents the size of the risk impact on the given project objective should the risk occur. Just like the probability scale, you can define the impact scale relatively or numerically. The relative scale can range from very low impact to very high impact, with points in the middle such as low, moderate, and high. As an alternative, you can define the impact numerically. It might be linear, such as the first point at 0.1, the second point at 0.2, and the 10th point at 1.0, or it might be nonlinear, such as the first point at 0.001, the second point at 0.01, and the third point at 0.1. Probability and impact matrix. Risks are prioritized according to the values of the probability of risk occurrence and the sizes of their impact on the project objectives, as estimated. Example, qualitative analysis. The values are recorded in what is called a probability impact matrix. For a given risk, its priority is determined by comparing its value in this probability impact matrix with the value in the reference probability impact matrix used as a lookup table. Even if your organization already has this reference matrix, you should examine it and tailor it to the needs of the specific project at hand. I will discuss the probability impact matrix in more detail later in this chapter. Risk reporting and tracking. The risk reporting part of the risk management plan describes what kind of content each output of the risk processes, example, risk register and risk report, will contain, and in what format. This is about how to document the output of the risk management processes. It may also include how these outputs will be communicated. Risk tracking describes how each risk management project used in the project would be audited. Obviously, should the performing organization decide to audit the risk management process, one should be able to track these activities. During the process of planning risk management for a specific project, you revisit the tolerance levels of the stakeholders for certain risks, and these levels may be revised. So, risk management planning is the process that generates the risk management plan document, which contains information that will be used in risk identification, risk analysis, and risk response. You cannot manage a risk if it's not identified. Identifying risks. Risks are identified by using the risk identification process. An unidentified risk is a danger lurking out of your sight and waiting to attack the project. The significance of the risk identification process cannot be overemphasized. You use the risk identification process to accomplish the following tasks. Identify the individual risks that might affect the project at hand, and also identify the overall sources of project risks. Document the characteristics and other information about the identified risks in a document called the risk register. Table 7.6 presents the identify risk process in terms of input, tools and techniques, and output. We can use the items in this table to perform the identify risk process. Performing risk identification. Remember, the goal of this process is to identify the individual project risks and overall sources of project risks. The risk management plan will give basic guidance on how to perform this process for your project, while here we will discuss in general how to do it. As the long list of input items in Table 7.6 indicates, risks are hiding in almost all areas of the project. The key to finding them is the uncertainty coming from various sources, example assumptions, ambiguity, estimates, ranges. That uncertainty gives rise to risks. So, as a starting point in identifying risk, you look for areas of assumptions, ambiguity, and estimates in the agreement, procurement documentation, and project documents and plans listed in Table 7.6. For example, the cost and duration estimates for project activities and the assumptions log are obvious places to start. You can use document analysis, discussed in Chapter 4 and other places in the book, to identify individual project risks. Furthermore, the knowledge base related to risk management from previous projects can also be reviewed with this technique. To identify the individual project risks and overall sources of project risks, you can also use other tools and techniques listed in Table 7.6, as discussed next. Data gathering techniques. To identify risks and project risk sources, you need to gather risk-related information from a variety of sources. The following are some of the information gathering techniques used for this purpose. Checklists. A checklist is a kind of to-do list, a list of actions to be taken or points to be considered. It can be used as a tool in this process, such as a checklist of all the documents that must be checked off to look for risks. Carefully prepared checklists in any process are great no-brainer time savers. Projects in the same organization will more often than not have similarities. As a result, you can develop a risk identification checklist based on the information gathered from a similar set of projects previously performed. Also, if you develop the risk breakdown structure, RBS, in risk planning, the lowest level of the RBS can often be used as a checklist, which should be the list of risk categories. Note: risk identification checklists are rarely exhaustive. Always explore what is left out of the checklist you are using. Also, make sure the checklist is up to date when you close the project to enhance its value for future projects. Interviewing. This is one of the common methods used for information gathering for risk identification. You interview the appropriate stakeholders and subject matter experts to gather information that will help identify risks for the project at hand. On the information gathered from different sources, you can conduct brainstorming sessions. Brainstorming, this technique, defined in chapters 3 and 4, can be used to identify risks and risk sources. The goal here is to get a comprehensive list of potential risks so that no risk goes unidentified. The project team, along with relevant experts from different disciplines, can participate in the brainstorming session. Brainstorming is better performed under the guidance of a facilitator. You can use the categories of risks or the RBS as a framework to keep the session focused on the issue. Once you have gathered the risk-related data, you can analyze it to identify the individual project risks and overall sources of project risks. Data analysis techniques. The data analysis techniques used to identify the individual project risks and overall sources of project risks may include those discussed in the following paragraphs. Assumptions and constraint analysis. Assumptions in the project, by definition, represent uncertainty, hence, risk. You analyze these assumptions to identify the risks. Assumptions and constraint analysis is the technique used to examine the validity of the assumptions and constraints and thereby identify the risks resulting from the inaccuracies, inconsistencies, or incompleteness of each assumption. For example, assume that there is only one person in the organization who has a rare skill needed for the project. An obvious assumption would be that the person will not quit the organization before completing the assignment. The likelihood of this assumption's being false, i.e., the inaccuracy of this assumption, amounts to the risk. Constraints, by their limiting factor, also create uncertainty, and thus risk. Root cause analysis, discussed in Chapter 10, root cause analysis is a powerful way to identify new risks by identifying the root cause of known ones. After you spot a potential cause for risks, it's simple to identify the risks resulting from that cause. Furthermore, if you know the cause of a risk, it helps to plan an effective response. In this technique, you obviously end up identifying the sources, i.e., causes, of project risks. You can also look for risks by starting with their impacts. SWOT analysis. While the root cause analysis technique looks into the causes of the risks to identify the risks, a SWOT analysis looks at the potential impacts of the risks to identify the risks. If you examine the strengths, weaknesses, opportunities, and threats, SWOT, of a given project, you will be exposing the risks involved. Remember that a strength is an opportunity, a weakness is a threat, and opportunities and threats are posed by risks. This helps broaden the spectrum of risks considered. For example, a strength of your project might be that most of its parts are well understood from previously executed similar projects. Therefore, the risks involved in those parts will be easy to identify. A weakness of your project might be that one of the parts involves new technology that is not well tested. So, this is a source of unknown risks. An opportunity might be that your organization will be the first one to take this product to the market. An example of a threat might be that the government is considering a bill that, if it becomes law, will have profound implications for your project. Note: a prompt list is a predetermined list of risk categories that can be used to generate ideas to identify individual project risks, and also is the lowest level in the risk breakdown structure, RBS. Of course, you can always use the judgment of experts on the topic. You will generally be using more than one of these tools and techniques to identify the risks. During risk identification, you might discover the causes of the risks, and you might even think of some potential risk responses. All of this is part of the output of the risk identification process. The output of risk identification. 2 documents, the risk register and the quality report, are initiated with the results of the identify risks process and are completed by other risk management processes. Risk register. The risk register is a document that contains the risk output of the risk identification process, i.e., information about the individual project risks. You will see later in this chapter that the risk register, which is initiated in the risk identification process, will also contain the information or results from other risk management processes. To begin, you store the following information from the risk identification process in the risk register. List of identified risks. These are the individual risks that you identified in the risk identification process, each risk with a unique ID. These risks should be described in reasonable detail, which may include the following: the risks, the definition and nature of each risk itself and the causes that will give rise to that risk. List of root causes of the risks. This is a list of events or conditions that might give rise to the identified risks. Updates to risk categories. Risk categories were originally identified in the risk management planning process. However, in the process of identifying risks, you might discover new categories or modify the existing categories. The updated risk categories must be included in the risk register. Risk owner. Each risk must be assigned an owner. If not identified yet, it will be in the perform qualitative risk analysis process. If the owner is known, it should be confirmed during the perform qualitative risk analysis process. List of potential responses. Risk response planning is a separate process that is performed after risk analysis. However, during risk identification, you might identify potential risk responses, which you must document in the risk register. These responses can be further examined and planned in the risk response planning process. Risk report. From this process, the risk report will have 1. Information about sources of overall project risks, answering the questions, what are the main risk drivers for this project? And 2. Summary of individual project risks stating their distribution across the risk categories, threats and opportunities that are present, their impact, and trends from them. Some results from other risk management processes are added to this report. Study checkpoint 7.3. Knowing the identify risks process, make lists of some EEFs and OPAs that can influence this process. The results of the risk identification process usually lead to the qualitative risk analysis. However, depending upon the project and the experience of the risk management team, risk identification might lead directly to the quantitative risk analysis and even to risk response planning. Analyzing risks. Once the risks have been identified, you need to answer 2 main questions for each identified risk. What are the odds that the risk will occur, and, if it does, what will its impact be on the project objectives? You get the answers by performing risk analysis, which comes in 2 forms, qualitative and quantitative. Perform qualitative risk analysis. This is used to prioritize the identified individual project risks by estimating the probability of their occurrence, their impact on the project objectives, and other risk factors. Perform quantitative risk analysis. This is used to perform the numerical analysis to estimate the combined effect of identified individual project risks and other uncertainty sources on the overall project objectives. Usually, you prioritize the risks by performing qualitative analysis on them before you perform quantitative analysis. Qualitative risk analysis. Because the qualitative analysis is an estimate, it is less precise than the quantitative analysis, which is based on numbers from detailed analysis and hence is more precise. However, qualitative analysis is quick and cheaper. It gives you some feel for the risks, and then you can determine which risks need to be analyzed further using quantitative analysis. Table 7.7 presents the qualitative risk analysis process in terms of input, tools and techniques, and output. We can use the items in this table to perform the qualitative risk analysis process. Performing qualitative risk analysis. Recall that the goal of this process is to prioritize risks by estimating the probability of their occurrence, their impact on the project, and other risk factors. To do that, you get needed information from the items in the input column of Table 7.7. For example, the risks that need to be prioritized are in the risk register, along with information about them. The information about assumptions and constraints in the assumptions log will help prioritize the risks, and information about stakeholders in the stakeholder register will help with assigning owners to each risk. How to information for the qualitative risk analysis can be obtained from the risk management plan, which also contains other useful information for this process, such as the following: roles and responsibilities for performing risk management, budgeting for risk management, definitions of probabilities and impacts, the probability and impact matrices, risk categories, risk timing and scheduling, stakeholders' risk tolerances, If any of these input items was not developed during risk management planning, it can be developed during this process. With this information at hand, you can use some tools and techniques to generate the output of this process. Tools and techniques for qualitative risk analysis. Prioritizing risks based on their probability of occurrence and their impact if they do occur is the central goal of qualitative risk analysis. Accordingly, most of the tools and techniques used involve estimating probability and impact. Assessment of the risk data quality. Qualitative risk analysis is performed to analyze the risk data so as to prioritize risks. However, before you do it, you must examine the risk data for its quality, which is crucial because the credibility of the results depends upon the quality of the risk data. If the quality of the risk data is poor, you might decide to gather better quality data. The technique used to assess the risk data quality involves examining the accuracy, reliability, and integrity of the data, and also examining how good that data is relevant to the specific risk and project for which it is being used. Biases in the attitudes of the data sources, example, people, must be collected and used as a corrective factor applied to the raw data to improve the quality. Assessment of risk probability and impact. Risk probability refers to the likelihood that a risk will occur, and impact refers to the effect the risk will have on a project objective if it occurs. The probability for each risk and its impact on each project objective, such as cost, quality, scope, and time, must be assessed. The definitions of probability and impact used in this assessment come from the risk management plan. Note that probability and impact are assessed for each identified risk. Methods used in making the probability and impact assessment include holding meetings, interviewing, considering expert judgment, and using an information base from previous projects. The assessed levels of probability and impact for each risk are recorded with the assumptions made in assessing. To prioritize the risks, you need to look at both probability and impact. Caution! Remember, the impact might be negative, posing a threat, or positive, representing an opportunity. Also, a risk with a high probability might have a very low impact, and a risk with a low probability might have a very high impact, and vice versa. Assessments of other risk parameters. In addition to probability and impact, you may consider other risk factors in prioritizing risks, example, risk urgency, manageability, i.e., ease of managing risk, controllability, i.e., how much the risk owner is able to control the risk's output, and connectivity, i.e., how many other risks this risk is connected to. For example, a risk that is going to occur now is more urgent to address than a risk that might occur a month from now. Similarly, the higher the value of the mentioned factor, such as controllability, the higher the risk priority is. Probability and impact matrix. Risks need to be prioritized for entry into the quantitative analysis, response planning, or both. The prioritization can be performed by using the probability and impact matrix, a lookup table that can be used to rate a risk based on where it falls both on the probability scale and on the impact scale, combined. There are multiple ways of forming a probability and impact matrix and determining the risk priority, such as the following. You can have a separate probability and impact matrix for each project objective. Determine the priority for each risk by doing the following. A. Combining the impact of a given risk on each objective, example, weighted average. B. Taking the highest value of impact on any objective as a final overall value. Table 7.8 presents an example of a probability and impact matrix by showing both the probability scale and the impact scale. Here is an example of how to read this matrix. Risk R45 has a probability of 0.70, that is, 7 out of 10 chances, for occurrence and an impact of 0.45 on the project objective for which this matrix is prepared. How to calculate the numerical scales for the probability and impact matrix and what they mean depends upon the project and the organization, and they are defined in the risk management plan. However, remember the relative meaning. A higher value of a risk on the probability scale means a greater likelihood of risk occurrence, and a higher value on the impact scale means a greater effect on the project objective, should the risk occur. The higher the value for a risk, the higher its priority is. For example, risk R38 has a higher priority level than risk R23. Note by priority value, in this discussion, we mean the priority level, as in qualitative analysis. We are interested only in relative level. However, each risk cell in Table 7 to 8, example, R14, can have a value computed from corresponding values of probability and impact, using the formula given in the risk management plan. According to the scheme in Table 7-8, each risk is rated, prioritized, based on the probability and the impact value assigned to it, separately for each objective. Generally, you can divide the matrix in Table 7-8 into three areas: high priority risks represented by higher numbers, such as R59, medium priority risks represented by moderate numbers, such as R23, and low priority risks represented by lower numbers, such as R12. However, each organization has to design its own risk score and risk threshold to guide the risk response plan. Note that impact can be a threat, a negative effect, or an opportunity, a positive effect. The same matrices will work for both threats and opportunities, but the interpretations will be different. Threats in the high priority area might require priority-related actions and aggressive responses. Also, you will want to capitalize on those opportunities in the high priority area, which you can do with relatively little effort. Risks posing threats in the low priority area might not need any response, but they must be kept on the watch list. Hierarchical charts, when you use not just probability and impact, but more than two parameters, for assessments of risk priority, then two-dimensional probability impact matrices, like a table, would not be enough. You will need multidimensional graphical techniques to assess priority for individual risks. For example, for two parameters in addition to impact, you can represent the values of the two parameters using the x and y axes, and the impact values can be expressed by the size of the data symbol representing the values of the two parameters. One such plot, where data points are disc-shaped, is called a bubble chart. All the multidimensional charts used to assess risk priority are collectively called hierarchical charts. Risk categorization: you define the risk categories during the risk management planning and risk identification processes. Now you can assign the identified risks to those categories. Because you now have more information about the risks for the project, you can also revisit the categorization schemes: categorization by risk sources, such as RBS, by risk-affected project area, such as WBS, or by root causes. Categorizing risks by their causes often helps you develop effective risk responses. Expert judgment: you may need expert judgment to assess the probability and impact of each risk. To find such expertise, look for people who have had experience with similar projects in the not-too-distant past. While weighing the expert judgment, look for possible biases. Often, experts are biased for their area against other areas. Of course, you will be using meetings in this process. You need to update the risk register and risk report with the result of the qualitative risk analysis. Output of the qualitative risk analysis. Updated risk register. The risk register was initiated during the Identify Risks process and is updated with the new information or results from the qualitative risk analysis. The updates include the following: probability, impact, and priority. Each individual risk is assigned an assessment for probability, impact, and priority of risk as estimated in this process. Owner: each individual risk is assigned an owner. Risk urgency information. Risks categorizations: make sure that each risk has category information assigned to it. This helps in various ways. Example: you can identify the common root causes of the risks and the areas of the project that might require special attention. Furthermore, categorizing risks can bring order to a chaotic situation and makes the management of these risks easier and more effective. List of risks: using some criteria, you can make different lists of risks for effective management. The following are some examples. Further analysis. List of risks for additional analysis and response, such as quantitative analysis. Watch list of low priority risks. This list contains the risks that are deemed unimportant by the qualitative risk analysis, but that need to be monitored continually. List of risks with time urgency. This list includes urgent risks that require attention now or in the near future. Tip trends in the analysis results. By examining the results from the qualitative risk analysis, you might recognize a trend for specific risks. That trend might suggest further analysis or a specific risk response. Updated risk report. The risk report is updated with the following information: a list of the most important individual project risks, example, risks at the top of the priority list based on the probability and impact matrix discussed earlier in this chapter. Priority list of all identified risks in the project. Summary conclusion. The assumptions log will be updated with new assumptions made or found in this process or old assumptions that changed, and the issues log will be updated with the addition of new issues or changes in the existing issues. The main result of qualitative risk analysis is the prioritization of risks based on a probability and impact matrix for each objective. So, each objective can have its own prioritized list of risks. Qualitative risk analysis is a relatively quick and cost-effective way to prioritize risks for risk planning. It also lays the groundwork for the quantitative risk analysis if one is required for some risks, as listed in the risk register. Performing quantitative analysis. Quantitative risk analysis is generally performed on the risks that have been prioritized in the qualitative risk analysis. However, depending upon the experience of the team and their familiarity with the risk, it is possible to skip the qualitative risk analysis and move directly, after the risk identification, to the quantitative risk analysis. The quantitative risk analysis has three major goals. Assess the probability of achieving specific project objectives. Quantify the aggregated effect of the individual risks and other uncertainty sources on the overall project objectives. Prioritize risks by their contributions to the overall project risk. Table 7-9 presents the quantitative risk analysis process in terms of input, tools and techniques, and output. We can use the items in below table to perform the quantitative risk analysis process. Nutshell of performing quantitative analysis. The fact that most of the input items for this process are related to project scope, schedule, and cost, the three fundamental components of the project base, is a reflection that risks can affect all aspects of the project. These input items also hold information about three key items that we need in order to start performing the quantitative risk analysis: individual project risk, reference points to measure the effect of individual risks, and reference points to measure the variability, i.e., uncertainty, as will be explained shortly. In light of this, performing the quantitative risk analysis process may be explained by the following steps in terms of the items from Table 7-9. 1. Get risk and how-to information. The how-to information about this is found in the risk management plan, which also explains the resources, such as analysis tools to use, and how often the process should be run. The needed information about individual project risks and about the sources of overall project risk can be found in the risk register and risk report, respectively. 2. Get information about reference points to measure effect of individual risks. The reference points, or starting points, as PMBOK calls them, refer to the planned values to build a component, perhaps $700, and the effect of the related individual risk is the deviation from the planned values, such as $100 more, if the risk occurs. The information about reference points can be obtained from the cost baseline. The information about other reference points can be obtained from some other inputs, scope baseline and schedule baseline. 3. Get information about reference points to measure variability, even before, or without any, individual project risk occurrence. The project has built-in uncertainties in the form of estimates. Therefore, the deviation or variability should be measured in reference to these built-in uncertainties. The information about these reference points used to measure variability can be obtained from cost estimates, duration estimate, and resource requirements. Also, the basis of estimate for uncertainties due and relevant entries in the assumptions log should be modeled in the quantitative analysis. 4. Check the result of quantitative analysis. When you use statistical methods in an analysis, there should always be a way to determine how believable the results from the analysis are, i.e., the confidence level. In our case, we can determine the confidence level by comparing the different parts of the analysis results with the information from the targets in the milestone list and schedule forecast, as well as the values of the quantities predicted in the cost forecast, BAC, EAC, ETC, and TCPI, etc. were covered in Chapter 7. 5. Model individual project risks, effects and other uncertainty sources. In Steps 2 and 3, we discussed measuring the effects of individual project risks on project objectives, such as cost and schedule, and measuring other uncertainty sources, such as assumptions, bases of estimates, and estimates. For quantitative analysis, we model uncertainty as probability distributions. The effects of individual project risks may be included in these distributions or can be modeled separately as probability branches. With this information at hand, you can use some tools and techniques to generate the results of quantitative risk analysis.